For this example, we're going to graph log base 1/2 of x. That's our equation right here, which is f of x. And to do that, we're going to use technology. So if you don't have a calculator out right now, pause the video and get your calculator out and get ready to go with that. The first step is to make a table of values. So our top row will be x and our bottom row will be f of x. And we're going to choose some values here. I'll pick, maybe 0. We'll do 1. And then we can do 2, 3, 4. And then I'm going to pick a special one. I'm going to skip a little bit and pick 8. We'll see how that works. Remember to type this into your calculator. You can type this in as log of x divided by log of 1/2. Or you can use the log base program if your calculator has that, and that's under the math menu if your calculator does have that. So the math menu is the button on the left-hand side just below your alpha key. And you can cursor down, I think it's like 0 or A down there is where the log base program is. So if you're used to using that, you can do that, or you can just use your log button on the left-hand side, lower left-hand side of your calculator. If we type in log of 0 divided by log of 1/2, our calculator actually can't give us a value because this position, the x position right here, which is called the argument, cannot be 0 or negative. If we type in log base 1/2 of 1, our calculator is going to give us 0 as the answer. Log base 1/2 of 2, or log 2 divided by log 1/2, our calculator is going to give us a value of -1. 1/2 to the -1 is 2. That's what the calculator is kind of doing, or the math behind it. And if we type in 3, we get about -1.6 here. Now that's just an approximation. And then 4 would be -2, and then 8 would be -3. I'm going to encourage you to pause the video, either hopefully did that before or right now, and make sure you're able to type this in your calculator and get those approximate values. After you're able to get those approximate values, what we're going to do is we're going to plot all these points. So let's plot 1, 0, and 1, 0 is a point right here. Then we've got 2, -1, that's this point. 3, -1.6 is about right here. Just do the best job you can with that. And then 4, -2 is here. Looks like this curve is shallowing out, kind of like the previous example. And if you're thinking about this in terms of exponentials, logarithms are just inverses of exponentials. So this should kind of look like an exponential graph, just not with the same orientation. And then 8, -3 is also another point that's going to be on this graph. And we can go ahead and try to draw this graph now. We can draw it nicely curved here. And then we don't want to level this out. We want to keep that graph going, in this case down. And then as we get closer to the y-axis here, we're just going to keep getting closer and closer and closer, but that's actually going to continue. And if you were to type this in your graphing calculator, some graphing calculators will leave off that last part. It doesn't know whether to fill in the pixel close to the y-axis or not, and sometimes they choose not to. So just be careful. Some of them will look like they end about right here, right about there, and they'll continue on like this for sure, but then that other part of the graph won't be there, but it definitely is. Our vertical asymptote here is x is equal to 0. That's also known as the y-axis, and that's the imaginary vertical line that the function gets closer to. If we continue with the domain here, those are the possible x values, and the possible x values are from 0 to infinity. Any value from 0 to infinity is good, except exactly 0. That's why we draw the parenthesis right here. The range could be any y value, from -infinity to infinity. All of those are possibilities on the graph. The x-intercept we can see is right here. So that x-intercept is 1, 0. We can also see that on the table above. So if you were to look at this guy right here, the y value is 0, the x value is 1. There's your x-intercept. And that's an actual point, unlike the domain and range, which are intervals of numbers. The graph does not cross the y-axis, so we can write none here for the y-intercept. There is no y-intercept. As we look at the end behavior, as x approaches infinity, we're wondering, what do the y values do? And it looks like the y values are continuing to get lower and lower and lower, and they will actually approach or get close to -infinity. The bigger we make x, the lower the y value is, although the graph does grow slower to the right as we make x bigger. As x approaches negative infinity here, well, that actually doesn't work. So we can't have an x value being 0 or negative, but we can approach 0. And we can take a look at the graph and see what the graph is doing. So if I'm a point on the graph and I'm trying to go to the left, trying to go to the left, trying to go to the left, I'm just going up and up and up. So our left end behavior as x approaches 0, f of x will approach infinity.